Hey everybody, this is Unit 3, Formative 3, Solving Systems by Graphing. Alright, so when we solve systems, what we're trying to do is basically just find where the two lines cross, or what point they share. Okay, so when we solve them, we're going to end up with an ordered pair as our answer. So we're going to end up with an x comma y as our answer. Okay, because we're finding a solution or a point that satisfies both equations. So in order to solve it by graphing, we need to first graph both these equations. So we're first going to graph the equation y equals 2x. Well, in order to graph that, we need to figure out where the y-intercept is. So if anything was being added, it would be 0. So the slope is going to be 2 over 1. The y-intercept would be 0. So we'd put a dot at 0. Then we're going to go up 2 over 1. Okay, the only difference with graphing these is I'm going to ask that you put more than 2 points. So we're just going to keep going up 2 over 1 and putting dots. Okay, or we could go down 2 left 1 and put dots as well. So there is your line, and draw yourself a nice straight line with that one. Okay, your other line, okay, has a slope of negative 2 over 1 and a y-intercept of 8. Okay, so we're going to graph that on the same grid. So we're going to go up to 8, put a dot, and then from that dot we're going to go down 2, right 1, down 2, right 1. Okay, well at this dot right here, okay, is where the lines are actually going to intersect. So I can actually just stop drawing my points there and draw my line. Okay, and here's where they intersect, so that's going to be the solution, okay, of my graph. Okay, so the solution would be, remember, to find the coordinate point we have to go to the right. Okay, so we walk to the elevator, right 2, and then we have to go up 4. So the coordinates of that point would be 2 comma 4, and there is your solution. Okay, remember, when you're finding a point, it's not rise over run, it's x, move in the x direction and then in the y direction. Okay, here's another example. Our first line here, we want to get both these graphed. Our first line has a slope of 1 over 1 because 1 is before the x, and then it has a y-intercept of 1 as well. Our second line has a slope of negative 1 over 1 with a y-intercept of 3. Okay, so let's start with the first one. We're going to start at 1, put a dot, and then we're going to go up 1, right 1, up 1, right 1. We're going to keep doing that. Okay, or we could go down 1, left 1. Okay, so there's your line. Okay, the reason you draw so many points is because it's easier to find where they actually cross then. All right, next one we have a y-intercept of 3, and then it has a slope of negative 1 over 1. So down 1, right 1, down 1, right 1. Okay, and if you notice, my line's already crossed. And they're going to cross right here at the point 1 comma 2 because I went over 1 up 2. All right, last one here. So we have y equals negative 3. So y equals negative 3 is right here, okay? And in order for it to be only y equals negative 3, it's going to be a horizontal line. And then x equals 5 is right here. In order for x to only equal 5, it's got to be a vertical line. Well, these two lines cross at this point right here, okay, which is going to be the point 5, negative 3. Because we go right 5, down 3. All right, and then the last thing to talk about is when you look at lines of a graph, okay, you have your two lines when they cross, okay, they're going to look like this, and they're going to cross in this point right here. So a graph that looks like this would have one solution. Okay. Next option would be is if you have a graph that just has a line and then has another line overlapping it in the same spot. Okay, this would be something like if you had the line y equals 2x plus 1 and then the line y equals 2x plus 1. Well, those are the exact same line, so naturally those are going to have infinite number of solutions because they overlap at every single point. And then your third and final option would be is if you have two lines that look like this. Okay, well those would come from if you have two lines that look like this as your equations, or something like this, where the slopes, okay, of both lines are the same. So if the slopes are the same, I'm going to have what's called parallel lines. They're never going to intersect, so therefore there would be no solutions if your graph looked like this. Okay, and those are just three different options that you can have when it comes to graphing system of equations. All right, we will see you later. That is it for graphing systems of equations.